Now that you have been introduced to three variable K-maps, here's just some more practice on how they work. So let's first look at this first K-map that I've drawn here. I haven't written in all the number indices in these cells because those are only useful when entering from a truth table into a K-map. But here what I want to do is what function is represented by each of these K-maps. So in this first one, remember we're going to be grouping ones because we're looking for reduced SOP form. Reduced SOP form. So we're going to group the ones in first as large a group as possible, and each group has to be a group of a power of 2. So here we've got this one and this one can be looped together. And then we have this one. This one could be looped with this one, but it could also be looped with this one. And it's better to loop it with this one because that way it's going to be covered in as few groupings as possible. So that's another goal of the K-map, is we want to use as few groupings as possible. So if we had included this one with this one in this grouping, we'd still need a third grouping to cover this one. So now we've only used 2 groupings to cover this whole K-map. Alright, so here the function is going to be f equals, this black grouping is in the C column, and it's also in the B column. Because as you can see, this group of 4 all share C together, and this group of 4 all share B. So these two are a BC. Now the blue grouping is in the A row and in the C0 columns. Do you see how it's in the A row and the C0 columns? So all groupings of 2 in a 3 variable K-map are going to have 2 variables in it. All groupings of 1 will have 3 variables in it. All groupings of 4 will have 1 variable in it. Alright, so let's look at this next one. What groupings can we do? Well, we can do, the largest grouping is a grouping of 4, which are these 4 right here. Oops, sorry about that. Can we undo? Oh, nice. And then our other grouping to cover that last one, we can group with this too, and now we've covered all ones. So f equals, let's do our black grouping first, that's in the A0 row, and then in the B area, because these two are B. And then our blue group, that's going to be, all of this is C. Alright, let's try the next one. Here we can group these two together. And now we also have to group this one. This could be grouped by itself, but it's better to go ahead and group it with the one adjacent to it, because we always want to do the largest grouping possible. So this is going to go with these two. So now we're going to have f equals, our black grouping is going to be A0, C0. And our blue grouping is going to be B, C0. So there you go. Those are the functions represented by these 3 K-maps. Now if you go the other way around and you want to enter this into a K-map, alright, so remember this is our A0, B0. Let's cross those two, and C0 is here and here. We're going to enter 1s for the A. So the A is this row, so we're going to get 1s in this whole row to represent the A. And then our B0, C, this is our B0 area. And our C is going to be these two, so that's going to be these two right here to represent B0, C. And the rest are zeros. So you can go both directions. You can get an equation from a K-map, and you could also put an equation into a K-map. Alright, so now we've just learned how to do reduced SOP form, but now we need to also know how to do reduced POS form. So just as we saw before, when you're looking at POS forms, you're going to be looking at the zeros rather than the ones. So in this case, we're going to be grouping zeros. So we're going to do reduced. Let me go back to black. Reduced POS form. Here we're going to circle the zeros and write equation for F naught. Okay, so we circle this group of zeros together because they can be grouped together. This zero is not adjacent to any other zero, so it can get grouped by itself. So now let's write the equation for F naught. F naught, remember we have our A naught, B naught, C naught. So this is going to be A, B, or our blue one by itself is A naught, B naught, C naught. So we wrote our equation for F naught. To get POS, we do De Morgan's, or sorry, to get, POS, we do De Morgan's, and we end up with F equals A naught or B naught, ended with A or B or C. Great. Okay, how about this one? Again, we're going to circle the zeros. We can actually group these 4 zeros into one grouping. So we're going to get F naught is equal to, what letter is that? C naught. This we don't really need any fancy De Morgan trick, but we can go F is equal to C is our final answer. This is going to be the same in SOP and POS.